Because I'm always making references to Star Trek and to Doctor Who. I'm just a nerd. I have been since, Tom Baker. Tom Baker is my doctor. That's how nerdy I am. I have my own doctor. So when we start talking about this, it starts to make sense. As a company, we've been around for 4.5 years. We're effectively a startup, but we're not a startup because we've been around and we've been under development for quite some time. We actually launched the product GA September 30th, 2015. It was the first day of the 2015 VMworld. And that was a very bizarre day for me because I had personally run around trying to make VMworld kick off by getting the booth and everything coordinated. And then I go walking in after being exhausted and it was 2 o'clock. So 6 a.m., we blasted the Twitterverse. The HX550 is here, we're GA, something we've been working towards. And at 2 o'clock, we won the Gold Award for Cloud Virtualization and Infrastructure. And that's nothing, I've never seen anything like that happen before. The baseline technologies that we bring to the table are very compelling. And it was that day that the industry said, what you're doing is interesting. And so now we're trying to move the company from being interesting to being relevant. And that's what we're doing. The first year of production was us going and collecting logos and talking to customers and getting our name out. This year, 2017, is about building more relevance, building a groundswell behind what we're trying to bring to the table, which is a new way of thinking about how storage is managed and a new way of how storage is actually put onto media. Luckily, we've had some companies that have jumped into what we're doing. They caught, so to speak, the concept. And these are some of the early adopters. These are companies that we've got going on. Array Networks, Nissan Foods, if you guys like ramen, these guys leverage us. So go get your top ramen. But there's a number of companies, big and small, that have come across. This is just a cross-section of companies. Like I said, one of the things, we're about 4.5 years old. We were founded in 2012. Our world headquarters in South San Francisco. And we have the entire engineering team out in Petah Tikva, Israel. We actually have one of our tech marketing people here, Edith. She's fantastic. She helps us build all of the content that we actually distribute to all of our customer base and people internally. The product itself, it looks like an array. It's got a really cool bezel, but it ultimately is just a 2U Xyratech Camaro. This platform is being used by a lot of other technologies. We chose it because of the performance characteristics it brings to the table and what we can do with the hardware. And one of the key things that we did with the hardware is make it as close to perfectly available as we could. We're shooting for 7 nines. We want to go beyond 6 nines. And one of the ways that we did this was by putting batteries in the PSUs, so the entire system is non-volatile. This does some very interesting things because it allows us to use DRAM as a non-volatile memory source. So whether you're putting conditioned power into it or not, we're protecting that content. And that just little piece gives us some interesting manipulations. I think this slide just likes to build itself out, so I'm going to let it do that. Traditionally, if you've looked at data protection, and one of the things that makes people very compelled to look at Reduxio, it's our backdating concepts. Everybody knows what snapshots are. Anybody in the room not know what snapshots are? So, EMC shop, NetApp shop, Hitachi shop, Compellent shop, Dell shop, what do you guys use for storage? Yeah, I'm pointing at you. What do you use? I'm not picking at anybody, but so snapshot-wise, how do you EMC? Okay, how many snapshots do you typically take a week? You don't use snapshots. Okay, so for us, we don't have snapshots, right? We've obsoleted snapshots. Typically, what you do is you set up a snapshot, and these snapshots have a particular schedule, and over time, these schedules have gotten and expanded out, right? So back in the day when I was with NetApp, we went from 7 to 16 to 254, right? Now they've got some large number to do that. We do the equivalent of 2.8 million snapshots in 28 days. That's kind of crazy. We don't take a single snapshot. What we do with backdating is we give you the ability to have an SLA to go back to the second if you wanted to for up to 28 days. And we chose that limitation based upon the size of the actual physical space in the box. Again, kind of another key thing to keep in mind. So our limitation is the amount of space in the device today. But that's what allows us to go back to that particular point in time. Now after that, after 28 days of to the second fallback, which is a game changer if you know how to leverage this, or even if you don't, you're going, wow, let's talk about strange events that we don't have any kind of control over. And I'll use a current example that we've been using quite a bit lately. But after that, you can go back to your traditional snapshot model if you want to have that, because to us, that's just another moment in time. And we choose to either keep it or not for referenceability. So if you want to go back to a nightly, an hourly, a monthly, a weekly, that's all available to you if that's the concept that you use for some kind of data protection or backup or fallback. But if you don't have that, we're going to give you an SLA of to the second, again, for up to 28 days. Now, if I want to set that for 4 hours, I could set that for 4 hours. If I want to set that for 4 days, I could do that for 4 days. But it's always there unless you turn it off. And you can, but why would you, right? Now, why is this powerful? We actually have a lot of marketing around a particular customer of ours. We've got stuff all over YouTube. We've been blastering the Twitterverse. We've been blastering pretty much social, LinkedIn. Barnstable Police Department. This is a police department in Massachusetts that actually, before they purchased a Reduxio box, they got hit by a ransomware incident. So CryptoLock crippled them. Started attacking, major applications in their environment, and they were no longer able to do what they do, serve and protect. And they went back to paper for a couple of days as their security people said, here's what we're going to do. We're going to pay. And so they went out, paid, sent out their data, got their content back, and in several days, they were up and running again. And that's several days scenario. Up until that point, they were back to doing it the old-fashioned way. Paper and pen, taking calls. 2 months later, they get Reduxio. Now, interesting thing happened because, oddly enough, I was in that loop. I was over in Burlington, Massachusetts, giving a lunch and learn, similar to what's going on here, and my phone blew up because I'm on one of the call trees for major incidents. And the SE for Boston was there. I was there, and both of our phones start popping. I'm like, what's going on? So he jumps on the phone, the support engineers are jumping on the phone. They got hit by another ransomware incident. This time, they were on Reduxio. And in 30 minutes, after testing 2 data sets, they went back to about 10 seconds before the incident occurred, as if it never happened. So you're talking about an SLA that gave them the ability to recover in minutes. Not just go back to a point in time, but they went back to multiple points in time, tested against that to validate, and said, finally, you know what, we're close enough, there's not been any change to the data sets. This is their 911 system. This is, yes?
How much did they pay the ransomware?
The first time? They did not let me know that one, but I know it was relatively significant. It wasn't a $500.
60.
I don't know right off the top of my head. And they didn't give me that information. Do you know, did you see anything on, did they ever tell you what they paid? All they told me was they paid. And if I was in their shoes, I wouldn't. Correct. So CryptoLock hit them. They went back to the people who hit them with the ransomware, and they sent them the Bitcoins, and they got the crypto key back. Crazy. If you look up Barnstable and Reduxio on YouTube, you will see their conversation about us. It's all there. It's all live. They are a wonderful referenceable site. These guys are fantastic at what they do, and they have a IT team of 1 and a couple of police officers. And with that, they were able to do exactly what I was talking about. And that's kind of powerful. And so if you apply that to enterprise or mid-sized businesses, giving this type of power, this type of SLA, whether you have the best intrusion detection or you have the best security detection, somebody's always going to do something outside of the box. You click the wrong thing. Hey, FedEx sent you this thing, you weren't there. Click this zip. Boom, oh Christ, right? We've all seen those emails. Somebody clicks them. All right. So again, this is just reinforcing that, going back to the single point in time. I can go back, I can make a clone. I can either revert the system if I want to, an entire system. I can revert a individual LUN, or I can make clones. Now, if I have this ability to do this, and this is just a ransomware scenario, let's talk about dev test. I've got a golden instance. Maybe I've done some upgrades. I can set that point in time, bookmark it, and say, okay, at midnight, I upgraded all my databases. I got corruption across 4 of them. Let's just go back to that point in time and rerun them again. Or I've got dev test instances. We've set up the profile across multiple systems, and now we're going to bookmark that. We're going to make 100 clones, 1,000 clones, and we're going to mount those on various virtual servers across the environment and do regression testing against them. And then we're going to throw out the stuff we don't need, and we're going to keep moving on with the stuff that we do need. All of this is deduped and compressed. So this isn't if I have a terabyte and I make 1,000 of them, right? I'm wasting all that space. If I have a terabyte and I make 1,000 of them, I have a terabyte. The difference is going to be the changes of the data over time as I manipulate it. Okay? So dedupe and compression is a pretty powerful thing. This is just, again, talking about our clones. I'm talking faster than the slides are at this point. Reversion is exactly what it sounds like. If there's a catastrophic event and I do not want to maintain any of that existing data set. So this is me getting all sci-fi-y again, right? So this is Star Trek, alternate universe kind of stuff. You shoot through one wormhole while the timeline's going on. So Kirk and his guys are over here. Maybe we've got Picard and his guys over here. Maybe we've got the, this new alternate universe where Spock just died, but there's another Spock. It's very bizarre to me. I don't understand. But each one is its own little wacky timeline, and that's all good. But the primary, that can be existing for the duration. Or I could just shut that down. Now, something catastrophic happens. Maybe the Borg hits every timeline, and we say that's a really bad thing to happen. So we want to revert to 20 minutes before the Borg find out that the Federation exists. So we revert the entire system. That's cool. You can do that. But then everything after that reversion, who knows? Right? That's like taking us back to the Paleozoic era, reverting and saying, hey, what's going to evolve next? Right? That's pretty disruptive. But if you go back and make those clones, that timeline can be doing whatever it wants. Or you can stall that timeline by just shutting down the systems. If I have that data set from that original timeline, I can do data forensics again, and I can bring it up and manipulate that content over time if I need to, while the other timelines take over as primaries, right? And I do that again with very little overhead. So every time I make a new clone, everything's based on the existing data set. That data set is, again, deduped and compressed, and the only real change is some new metadata that's created. It's very minute compared to the rest of the data on the box, and the system just keeps going as if the new timelines are primaries to their individual worlds. I talked a little bit about bookmarking, or at least I referenced it. Bookmarking is, hey, some of us have been around since we all had the old World Book encyclopedias, right? We'd do our reports, and we'd have to throw 45 sheets of paper in there to go back to find exactly what we were looking at. That's the concept of the bookmark. I might be able to go back to points in time, but then I have to keep an Excel spreadsheet or some other document that tells me what all these times are. Well, the bookmark lets me have the convenience of doing that on the box and actually referencing that. Whether I'm doing it through scripting, whether I'm doing it just through the UI, I can see that anything that I name with a particular bookmark, upgraded Oracle, right? No, that makes sense. So I can go back before the upgrade if I want to, right? Or I went from ESX5 to ESX6. All right, let's take that point in time, bookmark it. It's not really adding any more protection. It can, but it's just making a referenceable point for me to go to. And if I have referenceable points in time, then I can actually manipulate from that point in time without having to remember what time it was. So, making it easy. It's building out. So one of the things here, this is starting to talk about our leveraging of SSD, DRAM, and our dehydration engine, which we call NoDupe. So NoDupe allows me to take content as it comes into the box. This content has already been previously time-stamped. Throw that in the back of your head for what we enable. And it allows us, whether it's going to be SSD or hard drive, to optimize the content as it lives on or at rest on media. So in a traditional system, the ones that actually have just compression going on, they usually see 2x, maybe a little better depending upon what their algorithms are. But when you start seeing dedupe and compression, this is our tier X with NoDupe working together, you're actually going to see a significantly higher ratio because we are compressing content as well as anything that's duplicated. We only need one copy of it. So your efficiencies of scale are significantly better. And today, we're talking about a single box approach. But as I get into the conversation a little bit more, honestly, the bigger we get, the more efficient we become. The more data that we have in our system, the more deduplication we can do. Because there's just a larger data set to reference. And so it's a very interesting concept. Today, 2U box. Tomorrow, things are different. This is just our global inline memory dedupe. This is a new slide set for me, so my old one I was a little more efficient with. But I hate slide decks. I actually would prefer to do this whole whiteboard and make life easy. This is just kind of a referenceable slide as to what we're doing. This is inline deduplication. We're not putting content at rest and going back and doing a back-end process, moving content again. This is before it actually gets committed to memory. Everything is deduped and compressed. We also dedupe and compress the metadata. So we try to add efficiencies across every component of the device itself. So your data is getting smaller, the metadata set is getting smaller. When you're working with an expensive media like an SSD or a DRAM, you want to get the most out of it that you can. And we are not a pure flash solution. We actually leverage spinning disk. Today we have spinning disk, so that's our millisecond response time. Our SSD is our microsecond response time, and our DRAM is our nanosecond response time. Prior to GA, and this is before we went into beta, so in the alpha we actually had S3 hooks built into the system, so that's our tens to hundreds of milliseconds of response time. That is not on right now. The first year of production, we wanted to be out there, and we wanted to have a little more control of the device to make sure that serviceability was there, and we weren't, hit coming out of, that right hook coming in and hitting us right back in the head. We didn't want that. We wanted to make sure that we had a little more control of the environment, and we're actually going to be re-implementing these types of technologies in the next major release that we've got going on. Again, I'll be referring to that later on in the deck. I reference Doctor Who a lot and I reference Star Trek a lot because our UI looks like something off of the Next Generation. So all those touch screens that everybody was using to fly the Enterprise, this is what our system looks like. It was designed for touch. It's very simple to deploy. You don't need a CS degree to be able to manage the storage. And you can manage it pretty much from anywhere. So if you're off-site and you only have your iPhone, hopefully it's the big one because the little one's very small. We actually had one of the early customers completely set up the device and configure it via his iPhone. That was kind of crazy. He was on his internal network. It was, he could do it. That was cool. It's the first time I'd ever seen anybody do that. And that was all UI based. When Barnstable got hit, if I'm remembering things correctly, the IT guy wasn't even in the office when this all went down. He did everything remote. Again, it's the UI, it's very simple. We have a very robust CLI. CLI does everything that the UI does, but you have to like to script or actually like to write. It's very intelligent. It auto-finishes commands for you. It's very intuitive. But the REST API that's coming out with the next release is going to allow for quite a bit more integration. And right now, the UI actually uses the API in the back end, so we didn't, it's not a script kiddie for our CLI. It's actually using the API commands today. So it's very, very robust. And if it was darker, this would look prettier. This is our baseline dashboard. Our baseline dashboard comes with a number of widgets that are built into it. When you want to see the box and you want to see what's going on, there's actually a little X here in the middle. You click the X, it brings up the widgets, and I can slide those into the main windows for the information that's most important to me. I can see what's going on with the top LUNs in the environment, whether it relates to I/O or latency. I can see what's going on with the entire box as it relates to I/O or latency. I can see what's going on whether it relates to alerting. I just set it up so that when I log in, I see what's important to me. It's right there. It's very quick. Whether I'm walking around and it's on my phone or whether I'm walking around and it's on my desktop. And this is 100% HTML5 based, so it works on every major browser. So nice and simple. I talked a little bit about dev test. It's intuitive again with databases. We are a high performance array. We give sub-millisecond response time to about 160,000 IOPS in a single box. Right? The single device that we deliver today has a maximum size per LUN of about 100 terabytes of allocatable space. But this is all thin provisioned, so I can have a number of 100 terabyte LUNs on the device as long as I'm not gobbling up all that space. Because of NoDupe and our TRX engine, we see anywhere between 100 and 150 terabytes of usable space per 2U device. And the system ships raw with 40 terabytes. 32 terabytes are really what's allocatable after data protection schemes. The disks and the SSDs are all RAID 6 protected, so they can take a double drive hit and still continue on. We do full rebuild, yada yada. Everything in the system is designed to be an enterprise class device. And we're trying to shoot for 7.9s if we can. Getting into dev test, again, if you're leveraging backdating, you have a significant amount of flexibility, unlike you've had with any other system previously. You would actually have to take manual snapshots at some point in time when you were doing something and then be able to hopefully share those out depending upon the system. If you're using a system that is protecting your content and you don't want to give up overhead for some kind of performance issue, or maybe it's space, you don't use your snapshots, kind of like what you were talking about. So best practices are to always kind of have some kind of backup for your data set, or at least secondary copy, whether it's local or remote. Today, this is an in-box design, but I keep referencing what's coming. With Tier X and everything that we're dealing with, it has to do with the Tier X enablement. We are a tiered solution that just happens to be doing everything in-box today. So it doesn't matter if it's going to be VMware, it doesn't matter if it's going to be Microsoft Exchange. Anything that is going to see benefit from having a low latency, high I/O device over iSCSI is going to get benefit from Reduxio. And this isn't just a checkbox. We actually do things very differently than every other technology on the market. And that's key. We started with a different foundation. This different foundation enables us to do things that look similar to some other companies today because we came out with things that people see and expect. Because if you don't have a certain set of features, then you're immediately dismissed. Well, can you protect my data? Give me point-in-time copies. Of course we can. But we're just going to do it better. We're going to give you to the second. Right? We can do that because of a new metadata design, because we've added new metadata components. Time is a feature of our metadata. We track what, we track where, and we track when. And if you don't have those three pieces, you cannot rebuild the data set to any point in time. Now, this is the fun stuff. This is what's coming. Some of you guys have talked about, you've seen the UIs, you've played with the iPads that are over there. This is what we are working towards. We are a server-based solution, whether it's virtual or whether it's bare metal. We are 100% Ethernet-based today. The Ethernet curve is significantly higher, or actually the slope is better than that of fiber channel. If you're looking at throughputs and performances as well as latencies, Ethernet is the technology to back. And that's the pony that we're putting our money on. Scalability, that is key. Today, we don't really, if you want to say, hey, you've got one box, do you scale? Well, not out of the one box, but with what's coming, that's where our scale is going. We are not going to be a traditional scale-up solution where you just add shelves. And scale out as a N+1 solution is a little different than what we've got going on for scale. I'll touch on our scale as we go, but elastic is very key. Whether you're going to have on-prem, which we are right now, or be able to push out into a public or private cloud scenario. Right? If you don't have the elasticity to be able to expand your data sets between different latency media or technologies, you're going to be pigeonholed. And we're a next generation solution. The next interesting thing, and this isn't here yet, but this is coming, but we are working towards being fully multi-tenant. Because if you have a ability to be elastic and move into larger spaces, whether you're leveraging public or private cloud technologies, or maybe you're leveraging older technologies that are still on somebody's support matrix, right? Well, that means my storage pool is bigger. That means my SLAs can be more rounded. I can have different internal or external customers depending upon what my business is. And some of them don't want visibility of everything into everybody. So let's go multi-tenant so they can manage their own content and they can protect that content. Multi-class of content, that's just the tiering that goes on. Programmable, there's our API. And efficiencies. Well, this is that whole dehydration ratio that we're talking about, right? Adding the efficiencies of media on disk. This is what Reduxio is building towards, this concept right here. We released an array with the baseline technologies to deliver a next-gen solution by leveraging our data management technologies. What we want to have happen and what we're working towards. I can't say it's going to happen because that's NDA. Timings and everything. But if you have content that's living in San Francisco and there's a point in time where you need that content available at high performance, so local performance, in London or Hong Kong or Melbourne or where have you, you set that SLA. That data gets moved almost automatically. And we have all of the pieces in place to do this. You no longer have to have an asynchronous solution where you are going in and saying, here's my primary, here's my secondary. What you have is an intelligent tiering mechanism where you are saying, use this data set as a tier, use this data set as a full replicant. And now you can start moving content wherever it needs to go. And then wouldn't it be very cool if data lived over here and maybe somebody in Melbourne said, hey, I made a clone, and they brought that clone up in San Francisco. And because the metadata is what's being shared between the devices and the data blocks, well, the latency that I'm going to feel is on the first hit of the content because somebody's going to say, hey, I need this information. They start pulling it in the application. Whatever the latency between those two devices are based upon your pipes, that's going to be the first hit. After that, we are going to possibly deterministically figure out what content we actually need to move from Melbourne to San Francisco to guarantee the SLA, and that is high performance. So for all practical purposes, data can live here, but it feels like it's living over there. It's very, very cool. And that's the kind of thing when you re-look at how data lives on disk and on media, you can start playing these interesting, I don't want to call them games, but it's a manipulation of the content as it relates to locality and metadata, to be able to deliver quality of service to your customers that they've never been able to do before. So if it takes you a development cycle of, let's say it's 2 weeks to move data from point A to point B to get a full copy so that my engineers, we'll just keep using Melbourne as an example. In Melbourne, to get them the same information that's going on in San Francisco because of the change rate, well, that means that 14 days, they get to work with data that's 14 days old. Every 14 days. So they can start their dev test right there. Wouldn't it be cool if you could do that in 1 day? Wouldn't that be cool if you could do that in a matter of hours? That changes how people go to business. That changes how you deliver. That changes your go-to-business strategy, right? It's an interesting, interesting play. And when you break down what people need, and this is kind of features aside, we don't care about features. Features are great. You want to have features. You want to call them whatever you want. But really what you need to be able to deliver a true solution, and that's not me giving it to you. That is the business owners. This is the IT professionals looking at a technology and saying, what is going to enable me to do my job and improve my business? Well, For dev test, DevOps, backup, primary, what you need is you need global scale and access, right? You need multiple storage classes because not everything is going to need to be on the highest, most expensive media on the planet. If we can all afford Maseratis and Porsches, and then we would all drive them, of course. But it's the real world. You have to have different classes, right, of storage and media. Multi-tenant access. If you have a large pool, people want to see and have visibility into only their data sets. So you need to be able to move into multi-tenant access. Data services, that's that content moving around, right? That's being able to manipulate where the content goes. Data mobility, that is the actual movement engine underneath. For us, that's Tier X. That's already built and developed. Global data reduction, this is NoDupe. If you do not have this ability, then you are just adding to the mess, right? I might have a bigger pool, but having 100 copies of the same data makes absolutely no sense. So shrink it, make it efficient, add efficiencies. And again, like I said, the bigger you get, if you start looking at a metro, you start looking at a regional, you start looking at a global environment, if your dedupe goes to 3-to-1 locally, 5-to-1 citywide, 10-to-1 citywide, 100-to-1 countrywide. Who knows what it goes globally, right? It's really, really interesting, especially over drinks with Nir and Amnon, two of the founders, who have conversations about what the dedupe ratio of the globe would be if we actually took all the data and kind of good over bourbon. Unified management, make it simple, and the way to do that is through an open API. Does that make sense? So this is what we're trying to bring to the table. We're trying to bring these points in without having a structure around the grid. That's what we're calling it, the Reduxio data grid right now. There's probably going to be some marketing buzzword that's going to go around and they'll name it whatever. But if you do not have actual reasons for a business to move to a platform, a technology, then you're a checkbox. Then you're another Me Too solution, and there's enough of them out there. I know I've worked for almost all of them, at least the major ones. NetApp, EMC, IBM, Isilon, right? The big guys. This is a very compelling technology that enables a smaller business to have the features of an enterprise class business at a price point, a burden of entry, that is incredibly low. I don't like talking money, but list price is $1 a gig, and that's with 3-year service and support. It's pretty good. This is going to be one of the cool pictures on our new website when it launches in a couple of weeks. Any questions, guys? I know the fire hose went out, but I'd like to answer anything that you guys might have on the top of your head. Compelling, interesting? If you don't believe it, go check out the systems that we've got going on right now. The iPads, the Pros that are on our stands over there, those are connected to a live box actually back in San Francisco. So when you're running into, hey, the screen's not refreshing, that's actually the latency going on because of the network here. But those are live devices. I run my entire ESX environment over on these boxes. We run our dev test, at least for San Francisco, on these boxes. My entire real facility for dev test is in Petah Tikva, Israel. But sales and marketing is here in the US. And we are now, we are a US-based company. The world headquarters is in South San Francisco. We've got regional sales teams here in Chicago, or actually out in Chicago, that are covering Minneapolis. And we've actually have a pretty good partnership forming. You might have seen the guys who ran the event. So any questions, please come to us. Please come to these guys. Look me up. I'm here for a couple more hours. And happy to talk to anybody. All right? Thank you, guys.